All right, you guys, Mr. Medellin here, Mr. M. And I'm really digging these signs right here. I like that. Radiology with Mr. M. I like that. That's nice. That's cute. But today, we're going to be covering the X-ray circuit. So we'll be covering single-phase X-ray generating circuit, full-wave rectification circuit. So again, I got a couple students that reached out and asked if I can do the circuit. So we're going to do our best to do the circuit today, okay? So we're referring to the Carlton Adler textbook, and I believe it's chapter 6, I want to say. So chapter 6, you can reference the textbook for this as well. So let's go ahead and get started. All right, so the circuit is actually broken up into 3 sections. All right, we have the low voltage side, which is the primary. We have the secondary up here on this side, also known as a high voltage, and then we have the low filament. So again, it's going to be broken up into 3 sections. And when you go into the X-ray lab, you know, your X-ray lab rooms, your exam rooms, you're going to find out that this map that we're going to draw, it really is in different pieces, right? You have the console, right? And then you have a transformer system, and then you have the X-ray tube. So this graph that we're going to go over right now, it's going to make it look like one giant system, but it's actually broken up into separate pieces. Okay, so I'm going to do my best here. So I'm going to draw here. You know what I should do? I should do different colors, huh? I should do different colors. So I'm going to do this here. So we'll do this one, this color. Okay, and then we'll do red. Okay, we'll do red on the bottom. Here like this. All right, so this is going to be your primary circuit. This on the bottom is going to be your low filament circuit. And it actually kind of goes like this. I want to be as accurate as I can. All right. And then on the other side, let's choose green. So we'll do a green color. All right. So this is going to be your primary, also known as your low voltage section. This is your low filament here on this section here. And then over here, we're going to go ahead and draw your high voltage section. So I'm going to go ahead and go back to black. All right, so try to keep it simple. But I'm telling you guys, if you can map it out like this, there's no question that it can't ask you on the ART exam, our exam, in regards to the location of the devices that we're going to be describing right now. So we have here our circuit breaker. Okay, so I'm actually going to draw a handle, make it look like a big old Frankenstein type of lab, right? So we have the circuit breaker, and this is where you have incoming line voltage. Incoming line voltage. Now, incoming line voltage, we have in a regular household, we have 120 volts, right? 120 volts of alternating current. When it comes to our electrical systems and our incoming line voltage for the X-ray systems, we use anywhere between 210 volts to 220 volts. So just remember, for our systems, we require a lot more voltage, but remember, it's still alternating current, all right? So we have incoming line voltage here, and then I'm going to draw, maybe I did a little bit too big here. I'm going to draw one coil here, just like this, and then I'm going to jump to this side, and I'm going to go here like this, and then on this side, I'm going to draw more coils. All right, you guys see what I'm doing here? You guys see that? And then down here on the bottom here, I'm going to draw less coils right there, just like that. So you can see what I'm doing here. I'm starting off with the transformers first, right? So we have our autotransformer, we have a step-up transformer, and then down here on the bottom we have a step-down transformer. So this is your primary portion of the circuit. So this is primary, known as the low voltage. Here, this is your secondary, and this is going to be your high voltage portion of the circuit. High voltage, right here. Okay, down on the bottom, we're going to have what's called a low filament. All right, so your low filament is going to be responsible for your thermionic emission. It's going to be responsible for heating the filament on the X-ray tube that's going to end up on this side right over here. So we're going to start here with our first transformer. So a transformer is going to use alternating current. It's going to be allowing the current to go through the coil, and it's going to go from positive, negative, you know, it's going to go up and down, up and down. And when it does that, when you have this establishment of a field and then it collapses, it creates an electromagnetic field, right? So when you have a device that produces its own electromagnetic field, right, it's known as what type of induction? It's doing it all by itself. It's called self-induction, correct? So self-induction means it's creating its own electromagnetic field by itself. So this is what helps me remember this. You ready? Self, medical terms, okay? Can't forget about those. Medical terms, what's the medical term for self? It's going to be auto, that's right. So this is your autotransformer. All right, so autotransformer. Okay, it's a little messy right there, but self-induction, auto. Self-induction, auto. You guys get that again? So it's producing its own electromagnetic field. Now there's still a primary and secondary coil here, but it's got one coil of wire that's wrapped around, and it's going to produce its own electromagnetic field. So what's the job of the autotransformer? It's designed to change the voltage. It's going to tell the step-up transformer exactly how much voltage it wants to go through the system. So the autotransformer, its job is to vary the kV. So it's going to vary the kilovolts that are going to go through the system to vary the voltage. So some systems, if you guys have worked on different X-ray systems, you can turn the dial or press the button or you know, whatever you're making your changes on. You can go up in increments of 10. That's known as major kV changes. Some systems you can go between 1 and 2 changes. If you want to go from like 80 to 82, right, you just hit the button twice. That's going to be small increments. That's minor kV changes. Let's say you want to get to 100 for like a chest X-ray. You can go from 80 and click it twice, 90, 100, right, or press it, and it's going to go up in major increments. So in the reading, when you see that it has incremental changes or large changes, they're referring to major or minor kVp, all right? Now, that's the job of the autotransformer, is to vary the voltage. Connected to this, and this is not in the Carlton Adler book, but I'm going to include it here, you guys. It's called the LVC. Okay, not the LBC, but the LVC, right? So, line voltage compensator. So, line voltage compensator. Guess what that's going to do? If you said it, it's compensating, right? But what is it compensating? It's compensating the fluctuations that's coming from the line voltage coming in from the system. We don't want it to go through the rest of the system. So the line voltage compensator is going to adjust for fluctuations of the incoming voltage. If you guys ever notice the room gets dark, it gets bright sometimes, well guess what? You don't want that going through the system. So the line voltage compensator is going to adjust it for you. I'm an older tech. I've been in the field almost 30 years. And when I first started off, we had a line voltage compensator and a knob that we had to turn. Well, guess what? The new systems, you have a governor that's built into the system that's going to do the work for you. Okay, but we were talking about it. One of our students brought up a picture of an old line voltage compensator on a system that I've actually worked on. All right, I was like, oh, it brought back a lot of memories. But it was a manual line voltage compensator that we would have to adjust. All right, so we got autotransformer, we got line voltage compensator. Now, I'm going to jump over here to this transformer right over here. So this here, you guys, there's two sets of coils. There's a primary set of coil on this side, and there's a secondary set of coil on this side. Now notice there's more windings. There's more windings on the secondary side. So when you have more windings on the secondary side, the voltage is going to step up, right? It's going to increase. So this is known as a step-up transformer, also known as a high tension or high voltage transformer. So look at the number of windings. So on some of the test questions, it might say that, you know, which device has more windings on the secondary portion of the circuit compared to the primary? Well, they're talking about the step-up transformer. So sometimes, you know, a lot of us, we read something, but if you can't picture it, you're not going to understand it. I suggest that you draw it out. Okay, I'm a very hands-on visual type person. I like to draw things out for me to understand. You know, hence the drawings that we're doing in our videos, right? I don't like PowerPoints. A lot of the students know that. I provide them, but I like to draw and talk and go over the material and share it and have more of a conversation about it. So again, if there's more windings on the secondary side, that's going to be a step-up transformer, okay? Now, look at the turns in the primary, it's less. So if they say the wording the opposite, that the primary side has fewer windings than the secondary, that's going to be still a step-up transformer, okay? So the job of the step-up transformer is to step up the voltage, right? So think about this, step up the voltage. You're going to increase the voltage here. You're going to have an increase of voltage. Well, what is it going to do? It's going to decrease the current. Okay. All right, so you're going to have an increase of voltage and you're going to have a decrease of current. All right, so again, you're increasing the voltage, increasing the force, but the quantity is coming down. So one of the analogies I use is the water hose. You turn on a water hose, the water is going to come out, correct? You're going to have a certain force. You're going to have a certain quantity of water coming out of the hose. But if you relate it to a step-up transformer, it's like you putting your thumb over the nozzle. What's going to happen? The water is going to shoot out faster and harder, correct? But the quantity of the water is going to go down, okay? So again, it's like putting a nozzle or putting your thumb over there. That's what the step-up transformer is doing. It's increasing the force, but decreasing the amount of current, all right? Now, on the lower end here, we have here still a primary side and a secondary side. But take a look. The secondary transformer here, you guys, I'm sorry, the step-down transformer, take a look at the secondary windings. Do you see how they're less? So when you have less windings on the secondary side, what do you think is going to happen to the voltage? The voltage is going to go down. But what's going to happen to the current? Remember, there's an inverse relationship right here. So the current is going to go up. And we need the increase of current to, guess what? Heat up the filament, right? We need that thermionic emission. And to get that, we need to have the right amount of electrons to heat up the filament, correct? Now, so again, I'm just getting excited about this. It's pretty cool. You guys, again, you know, for us to understand this, it just blows my mind. We're not going to be electricians at the end of the day. We're talking about that, right? But you get a chance to understand how you're converting electricity, a flow of electrons, into X-rays, right? And as a tech, I'm not going to lie, I forgot about the magic behind the scenes. But when I got into education and teaching, it's like, wow, I kind of took that for granted. All these things are happening, and you don't really think about it because you're just focused on the patient, getting the exam done, and getting on to the next patient, and getting that exam done, that we forget about the magic behind the scenes. All right, so we got a decrease of voltage and an increase of current, correct? Now, how is this all happening? Well, remember the electromagnetic field that's created, correct? Well, here you have one coil, here you have two. So when you have two sets of coils working together, they don't touch. But the electromagnetic field from one side is going to go ahead and affect this other side, and you're going to have an amplified electromagnetic field because of more windings of the coil. So this induction, when you have two sets of coils working together, this is known as a mutual induction. All right, so here you're going to have a mutual induction occurring between the step-up transformer, and you're also going to have it occurring with the step-down transformer, because why? There's two sets of coils, correct? So mutual induction is going to occur when you have two coils that are working together. They don't touch, but again, they get excited because the other side's getting excited, right? So mutual induction is going to be for step-up and step-down, okay? So take a look where we're at. We got autotransformer, we got step-up, we got step-down, correct? So the next device that I'm going to draw here is going to be a rectifier. Okay, and I'm going to draw little symbols on this here, you guys. So the rectifier is going to be on the high voltage section. And the rectifier, what does that do? If you said rectify, that's correct. But what does rectify mean? It means to fix, to correct, right? To make an adjustment for, to make right. So a rectifier, we can't have alternating current going into the system to create X-rays. We need it to be converted into what's called pulsating DC or direct current. So the rectifier is going to convert AC to DC. All right, we need it to go from this to, all right, this, pulsating DC. We can't have this negative and positive, negative, positive, negative, positive, reversing the polarity. It has to be in an even just blast of, energy that we need, a blast of electricity, a blast of X-rays. So we need to convert AC to DC. And that's what a rectifier is going to do. So if you have 4 of these symbols, that means there's 4 diodes. Now diodes, we said, are made of silicon. So silicon is a great material to use to get the electrons to go into one direction. The diodes here are going to be used to go ahead and allow the electrons to go into one direction. Instead of making a left-hand turn, the car as you're driving, it's going to make you go under the parking structure around and make a right turn. So it's almost like a traffic controller, right? That's causing them to go ahead and say, okay, I can't make you a left turn here, but you can go around and then make a right turn. It's making it flow one direction. So there's your rectifier. So notice it's on the high voltage or secondary portion, correct? Now, the other device that we're going to talk about is the X-ray tube. So the X-ray tube is going to be here. So electricity is flowing through all the system. So here we're going to have your anode, and over here we're going to have our filament, and we're going to have the cathode. All right. So I'm going to leave that alone for right now, and we're going to go back to this section here. So notice we started with the transformers. Then we added the rectifier and the X-ray tube. So now we're going to go ahead and talk about the other devices that we need to understand. And one of the devices that we're going to talk about is the exposure switch. So the exposure switch is going to be here. All right, so this is going to be, I'm just going to put EX, P, and then an S, exposure switch. So the exposure switch is found between the autotransformer, line voltage compensator, and the step-down transformer. All right, so there's the exposure switch. And this is what gets students all the time. The exposure switch is designed to initiate this exposure. It doesn't control the length of exposure. That's going to be relying on the timer circuit. So again, your exposure switch only gets it going. All right, it initiates the exposure, but the timer circuit, I'm going to draw right here. I'm going to draw a little clock. Okay, just like that, old school clock. That's your timer. So the timer now is found between the exposure switch and the step-up transformer. So you got to know the locations of the devices. So this is why I say draw it out, make a map of it. Then you have something you can refer to. All right. In class, we practice on studying the exposure switch, knowing where the timer's at, knowing where these are at, right? And even though the ART has removed the copy of the diagram, they still ask you questions relate to where these devices are at or what they do, right? So we have our exposure switch here, right? Now, we're going to go down to the bottom here, and I'm going to draw this little zigzaggy line right here. So this little zigzagging line right here, guys, is called a rheostat. A rheostat is a variable resistor. And this is what's known as your MA selector. Okay? A lot of you have variable resistors in your homes. A lot of you have what's called a light dimmer. So you can either go up and down and your lights are going to get brighter or dimmer, or you can turn a dial and it's going to get brighter or dimmer, right? That's called a rheostat. That's known as an MA selector. So think about it. If you go up on your dial, you're up on your dial or up on your switch, it gets brighter. Do you know why? Because you're sending more current to the light and you're going to get brighter. If you decrease the current, it's going to get dimmer. Well, guess what? That's still going to control the amount of thermionic emission and quantity of electrons that will become X-rays. So the rheostat, variable resistor, and MA selector is on the low filament portion. Okay? So again, your MA selector is going to be found between the incoming line voltage here and the step-down transformer over here. Okay, so again, the textbook has a little chart for you to look at to see where these devices are located, but hey, we don't need the chart, we got a chart right here, right? Okay, so now, these are your major components right over here. You're gonna have a meter to monitor the MA, you're gonna have a meter to monitor the KV, you always have to have an MA meter, you always have to have a KV meter, and you have to have a timer. That is required by law to be designed within your system. Now, we got one more last piece here, you guys, and we're done. You have the X-ray tube. So the X-ray tube requires high voltage to go ahead and spin that anode and to get to pull the electrons across. The MA selector is going to control the amount of current that we want to heat up the filament, and that's what we have for the thermionic emission. So the X-ray tube, you need to know, is on the high voltage side. In fact, on the back of the tube, you have these thick cables, and they're called high voltage wires. And it says, caution, do not take apart, do not, open. And that's part of your high voltage system. Now, you as a radiographer, guess which side of the system that you work with? Are you going to work with the high voltage side? Or do you think you're going to work with the low voltage side? You're going to work with the low voltage, okay? Because there's less risk, there's less chance of you getting injured by working with high voltage. So if you take a look here, here is your basic single phase full rectification circuit. I know it's a little different from the high frequency X-ray journeying circuit, but this here, you guys, this is what we still kind of have to understand. And I'm hoping by going over this material, it'll help you understand. I'm looking at it now and I'm like, wow, that's a lot of stuff on there. But again, if you saw how we started off with the transformers, autotransformer, step-up transformer, step-down transformer. Then we added the rectifier. We put the X-ray tube over here. And then we added the exposure switch and the timer and then the rheostat. So if you kind of just map it out that way, I'm telling you guys, it'll help you navigate through the circuit, understand the devices, and understand what their purpose is. So I'm hoping this is going to help you all. And if you have any questions or comments, please reach out to us and we'll get back to you as soon as we can. Thank you. Hello everyone, you guys. Thank you very much for watching the videos. I'm hoping that they're helping you out. Please make sure that you subscribe and that you hit the notification bell to be notified about new videos. Again, remember to be good to yourself and be good to others. Thank you.